Telescopes from Hawaii to South Africa caught it first. The event unfolded quietly, almost like a whisper among the stars, yet it was impossible to ignore. Then NASA confirmed it. A new object, uncharted, unbound by gravity's expected rules, and most terrifying of all, coming from outside our solar system. At first, it appeared to be nothing more than another rock drifting aimlessly through the dark, silent expanse of space. But within hours, patterns began to emerge that unsettled even the most seasoned astronomers. Its speed was too fast, its trajectory too perfect, its reflections far too bright for any natural object. And when scientists traced its path backward, what they found made the blood run cold. This mysterious object was headed straight toward the heart of the system. For decades, we've believed that space is silent, still, and indifferent, a cold backdrop to our tiny, fragile existence. But now, as this enigmatic object barrels through our cosmic backyard, the James Webb Space Telescope has turned its powerful gaze upon it. And what it has started to reveal is something we may not be ready to face. Because some are now asking questions that were once confined to the realm of science fiction. What if this isn't just a visitor? What if it's watching us back? First detected between the 25th of June and the 29th, the object, now officially named 3I Atlas, appeared on the radar of Atlas, a high-speed skyscanning system designed specifically to catch potentially hazardous objects before they have a chance to surprise us. But this time, Atlas didn't find just another asteroid or comet. What it caught was different, unsettling, and inexplicable. Its speed exceeded 152,000 miles per hour, far faster than any conventional space debris that might wander into our solar system. Its orbit didn't follow any of the known gravitational loops of comets or inner solar system wanderers. And when astronomers reversed its trajectory through complex simulation models, its origin pointed not to the Oort cloud, not even to Neptune's icy frontier, but to interstellar space, possibly all the way from the core of our galaxy. This wasn't a leftover rock from the formation of the solar system. No, this was something far older, something that had been traveling through the dark for tens of thousands, perhaps even millions of years, unseen and undetected. And now, suddenly, it had crossed the threshold into our solar domain. But the deeper mystery wasn't just where it came from, it was why now. Because before 2017, we had never observed a single interstellar object passing through our neighborhood. Now, in the span of just a few short years, we've seen 3. And each one has been stranger, faster, and more puzzling than the last. After the initial confirmation, scientists around the world scrambled to secure time on the most powerful space observatory ever built, the James Webb Space Telescope. Designed to peer deeper into time and space than any instrument before it, Webb was now focused not on the distant galaxies of the early universe but on something far closer and potentially far more unsettling. The object's brightness didn't match its apparent size. Based on the intensity of the light it reflected, it should have been massive, perhaps the size of a small moon. But careful measurement suggested it was much smaller, which meant its surface wasn't behaving like rock or ice. Instead, it was behaving like metal, highly reflective, cold, and possibly hollow. Harvard astrophysicist Avi Loeb, who had previously suggested that the 2017 object Oumuamua might have been artificial, once again stepped forward with a controversial warning. He urged scientists to look for signs of non-gravitational acceleration, small but measurable deviations in its motion that couldn't be explained by the sun's gravity alone. If such deviations existed, they might indicate that the object wasn't simply drifting but navigating. And if it's navigating, then we're not watching a rock. We're watching a decision. To fully understand how serious this discovery is, we have to revisit the 2 interstellar objects that came before it. In 2017, Oumuamua burst into the scientific world with its strange elongated shape, its lack of a cometary tail, and its mysterious acceleration after passing the sun, despite showing no visible signs of gas release or propulsion. Then, in 2019, Borisov entered the picture, a comet, yes, but faster and more volatile than anything ever seen before. With each of these objects, we were left with more questions than answers. But 3I Atlas is different. It combines the inexplicable brightness of Oumuamua with the hyperbolic trajectory of Borisov. It doesn't behave like a rock, but it also doesn't fit neatly into the category of a comet. And now, astronomers are beginning to consider something even more radical. These may not be isolated events. They may be part of a pattern, a wave, or even a slow, deliberate sequence of contact disguised as randomness. Because for centuries, our skies were empty. Then suddenly, they weren't. And the only variable that has truly changed was us. Among all the scientific papers, trajectory models, and observational data lies a question that no major institution wants to address publicly. What if it's not natural? When you remove everything that doesn't make sense, when the brightness is too high, when the path is too sharp, when the motion isn't gravitational, you're left with a possibility that is too terrifying for most to say aloud: artificiality. Not aliens in the Hollywood sense, not flying saucers and little green faces, but probes, autonomous systems, artificial messengers sent long ago from places far away. AVI-Lab suggests we may already have missed the message from Oumuamua, and that 3I Atlas could be our second chance. Its surface properties, its anomalous speed, and the precise timing of its arrival all point toward intentionality, or at the very least, engineering. The James Webb Telescope will continue to monitor its thermal signature, its spin, and its trajectory. But what if the answers we're about to find aren't about what it is, but about who sent it? Because in a cosmos that's 13.8 billion years old, the most terrifying discovery wouldn't be that we're alone. It would be that we've been watched all along, and only now are we smart enough to notice. As days passed, the data from the James Webb Telescope and its supporting ground-based counterparts began to converge on something deeply unsettling. The object was accelerating, ever so slightly, but not in a way that solar radiation could explain. This wasn't Carmateri outgassing. There was no tail, no particle plume, no traceable emission. And yet, the object continued to alter its trajectory, slipping past predicted paths with eerie precision. Webb's infrared lens confirmed a faint but consistent thermal signature. Not chaotic like an ice body, but stable, patterned, and directed. The anomaly echoed the same behavior seen in Oumuamua, where a similar unexplained acceleration had once prompted a quiet panic behind closed scientific doors. This time, however, it wasn't dismissed as noise or coincidence. It was measured, tracked, and now feared, because the very act of acceleration without force suggests something else. Something with control. And for the first time, scientists began to whisper in internal memos what they couldn't yet say on record: we're not just observing this object. We might be under observation, too. With Webb's advanced instruments aimed directly at the object, the team at NASA's Goddard Space Flight Center performed a full spectral analysis. They expected to find the usual suspects: silicates, iron, or perhaps ice, the typical chemical fingerprints of natural celestial debris. But what they found instead shattered expectations. The surface composition didn't match any known asteroid or comet profile. Certain absorption lines suggested the presence of advanced carbon structures, materials far more sophisticated than what is typically associated with random geological formations. In fact, these structures were more commonly linked to engineered materials than to anything formed by nature. In simpler terms, it looked manufactured. Not only was the reflectivity unusually high, but there were subtle hints of symmetry in the way the object spun, something almost unheard of in random cosmic debris. One side absorbed more heat than the other, almost as if it had been intentionally designed to regulate its temperature. Even more baffling, fluctuations in electromagnetic readings hinted at internal complexity, layers or cavities hidden beneath its reflective shell. Whatever this was, it wasn't a typical chunk of rock wandering through space. And if it isn't a rock, what is it? That question began to echo from NASA's Jet Propulsion Laboratory to the European Southern Observatory to the classified corridors of national defense agencies. Because if nature didn't make this thing, someone did. As public excitement grew, a new kind of silence began to settle in. The very agencies that initially released trajectory data, brightness curves, and observational updates, NASA, ESA, and India's ISRO, suddenly pulled back. Mission pages stopped updating without explanation. Observational timelines vanished overnight. Requests for raw web data were met with vague replies or denied altogether, citing internal review. Journalists and researchers who submitted Freedom of Information Act (FOA) requests received heavily redacted documents, with entire sections blacked out. Whispers began to leak from inside observatories, researchers pulled from teams, specialists reassigned to unrelated projects, and access to telescope feeds quietly restricted. The public, which had initially been fed a narrative of curiosity and discovery, was now met with closed doors and silence. Why? What changed? Analysts in the astrophysics community began to suspect that something had been found, something extraordinary, and that governments were scrambling not just to understand it, but to control the narrative. Because once a discovery reaches a certain threshold, one that challenges the frameworks of physics, security, or belief, it no longer belongs to the realm of science. It becomes a matter of control. And control in space, as history has shown, is as much about silence as it is about signals. As the object continued its silent glide through our solar system, a sobering realization began to dawn across the scientific world. This was no longer just a data point on a chart. It was an inflection point, a moment in time where centuries of assumptions about space, solitude, and human centrality were being shattered. If this object is artificial, then it came from a civilization far older and far more advanced than ours, one capable of building something that could survive millennia adrift in the void. A civilization that might not need to send radio messages, because its very presence is message enough. And if it isn't artificial, then we've just discovered a natural phenomenon so advanced, so alien in its behavior, that it mimics design to the point of deception. Either way, the conclusion is the same: our understanding of the universe is incomplete. And James Webb just held up a mirror to that ignorance. We are no longer staring into the void. The void, perhaps, is staring back. And what it sees might finally be worthy of attention. Amid the escalating mystery, a deeper, more disquieting idea began to ripple through the scientific community. It wasn't discussed in public conferences or peer-reviewed journals, but in hushed conversations, encrypted emails, and off-the-record discussions between researchers. What if this object, this silent interstellar visitor, was never meant to be found by accident? What if the timing of its arrival, the growing intelligence of our instruments, and the specific orientation of the James Webb Telescope, all converging at this precise moment in history, wasn't random at all? What if it was the final variable in a cosmic experiment? Not just an artifact drifting through space, but a test. A probe waiting to be noticed by a civilization that had finally reached the threshold of detection. A signal that whispers, "You're now intelligent enough to find us. Now, let's see what you do next." Think about it: radio silence for billions of years. No messages. No signals. No obvious visitors. And yet, now, as artificial intelligence advances, quantum physics accelerates, and humanity begins to stretch its fingers beyond Mars, something appears. Something quiet, something precise, something intriguing enough to lure our greatest telescope off its deep sky missions and onto it. Could this be the moment where we become the data point? Where our reaction